In this video, we are going to study the types of semaphores. So before knowing the types of semaphores, so once again I will revise the what you mean by semaphore. So semaphore is nothing but it is one of the solution of a critical section. So as we already studied the some two more solutions except semaphores, that is Peterson solution and the test and set and test, and similarly a swap instruction. So Peterson's is a software based solution, and similarly set and test and the swap instructions are the hardware based solution. So now a semaphore, and one more thing is Peterson's solution, it works only for two processes. So if more than one process wants to access the a critical section, or what is the solution for the multiple processes is nothing but the semaphores. So it is one of their synchronization tool. So what is semaphore here? So semaphore is nothing but it is an integer variable. Actually it is an integer variable. Okay, so it is initialized, or from its initialization it is accessed only through two atomic operations. Only we can access the value of this semaphore integer variable by using only two operations, that is wait and signal. So now already I have defined the what is wait and what is the signal operations. So as you might be knowing that a semaphore semaphore is an integer variable. It is denoted by the symbol s, and similarly wait is denoted by p, and similarly a signal is denoted by v. So now how you can define the wait operation here? So wait is again, this is an one of the atomic operation of a semaphore. So it is as the name itself indicates here, the wait is nothing but a semaphore is going to wait for the the process is going to wait for the semaphore to become positive. Okay, means as I told, a semaphore is nothing but an integer variable. So then if it is an integer variable, or whatever the variable data type, so what is the value of this semaphore you should know. So now if the semaphore, so in wait in wait it is going to wait for the semaphore to become positive, means it is going to decrement the value of an yes if it is positive. Clear? So if it is positive, it is going to it decreases the value of an yes, value of an argument yes. Okay, so if yes is a negative or 0, then no operation is going to be performed. So that same thing, that is I have the structure of wait operation already I have discussed in the last video. That is wait in a while loop we are checking whether that a value of a semaphore is less than or equals to 0. If less than or equals to 0 is a true, it remains in a in a infinite loop. If not so, then it has to decrement the value. Okay, so when it is going to decrement the value, when the semaphore value is a positive or more than 0, means when s is less than or equals to 0, we are not going to do anything. And if s is a more if s value is more than 0, okay, then that time we will decrement the value of yes. So similarly signal is what here, it increments the value of its argument. So in wait we are decrementing the value of s, and similarly in signal we are incrementing the value of a yes. So incrementing the value of an s is nothing but s plus plus. So s is nothing but the semaphore here. So now as I told, the wait operation is going to be performed at the entry of the critical section. So you need to remember the structure of a critical section problem before solving these solutions, that is Peterson solution, or it may be a test and set or swap instruction, or it may be a semaphore. Okay, so now it's similarly a signal is going to be performed at the time of a exit from a critical section. Okay, so that is entry of the critical section is going to be controlled by the weight operation, and similarly exit will be exit is going to be controlled by the signal operation. Okay, so now in this I will explain the types of semaphores. So what are the types of semaphores? There are two types, counting semaphores and the binary semaphores. So what is counting semaphores here? So counting semaphore is what here? A counting semaphore can take the positive integer values, or it ranges over the unrestricted domain. Means counting unrestricted domains means there is no restriction on the integer value range, means like 0 to 1, or you may tell integer value, there is no restriction in the range. It may be a 1 to 100 or 100 to 200, like that. The range is not restricted, whatever it may be a value of a semaphore, that is range or domain of the semaphore variable is not restricted, you can see. So now these counting semaphores are used to implement or bounded weighting concurrency, or we call a bounded concurrency. So we have studied the three requirements or three conditions of a critical section problem, that is mutual exclusion, then the weighting, that is Busy weighting, and the bounded weighting. Okay, so now binary semaphore. So binary semaphore is what here? There is a restriction. Okay, there is a restriction in the range of a value of a semaphore value, that is either it may be a 0 or either it may be a 1. So hence the name is a binary semaphore. These are used for implementing the mutual exclusion. Okay, so now counting semaphores are implemented for your bounded waiting time. Then similarly the binary semaphores are used for implementing the mutual exclusion. So you may call it as a mutex in short. So as I told, a binary means only it can take only two values, that is 0 or 1, and binary semaphore is initially the value of a semaphore will be always 1. Okay, so now this is the a critical section with semaphore. So we know that, as I told, the weight is controlled by the entry of the critical section, and similarly the signal is controlled by the exit from a critical section. So to enter into the critical section, we have to first execute the wait operation, then if it is so, then only we are allowed to enter into the critical section problem. Okay, so otherwise it is going to, otherwise it has to wait. So if it once it completes its execution in critical section, obviously it need to exit. So then how it is going to be exited from the critical section? By using the signal operation. So after that it is going to execute the remainder section of a program. Okay, so here ends the semaphores. So in next video I will explain what are the classical problems of a synchronization. Okay, so again this this unit is a very, very important. Clear? So first you need to understand the critical section structure, then you go with all these three solutions. It may be a Peterson solution, it may be a test and set, or it may be a swap instruction, or it may be a semaphore. Clear? Thank you.